Hi, welcome back. I want to share an interesting read with you. Now, do you know that geometry and algebra are considered one of the oldest branches of mathematics? Archaeologists have found out many such problems written on papyrus by ancient Egypt civilization. So, I'll share one such problem. Now, in ancient times, workers were paid in terms of bread. So, the problem is that we have to divide 9 loaves of bread among 10 people such that there should not be any fight among them. Now you would say it's very easy, we'll just give 9 by 10th piece to each one of them. But considering those times, it was very difficult to get 9/10 of a bread. So I'll share you how they used to solve these type of problems in daily life. Now you would say the easiest way would be to give each one of them 9 by 10th. But there is no mechanism to divide exactly one bread in 9 by 10th piece. So they took the first 5 breads and they have divided into halves. So we have 10 halves. They have taken next 4 and they have divided into 1/3. So now we have 12 1/3 pieces. Now these are 10 pieces and we have now 2 extra pieces. These 2 extra pieces were further divided into 1/5. So now we have 10 pieces of each. So now we have 10 halves, 10 1/3 and 10 1/15. So probably they must have kept 3 stations where one station will distribute half, another one will distribute 1/3 and third station will distribute 1/15 piece. So each one will get half, 1/3 and 1/15. And that's how they used to get one loaf of bread every time. Interesting, right? Alright, let's start with solutions to challenge problem number 7. Alright, let's start with question number 1. Here we need to find the sum of reciprocals of binomial coefficients. So let's call it as S. This will be equal to 1 upon NC0 plus 1 upon NC1 plus 1 upon NC2 up to 1 upon NCn. Now we know that NC0 is 1 and NC1 is n. Similarly, NCn minus 1 is also n and NCn is 1. Therefore, we'll get 2 plus 2 by n plus 1 upon NC2, so on. We can surely write S as greater than 2 and it will be less than 2 plus 2 by n plus 1 upon NC2, 1 upon NC2, so on, n minus 3 times NC2. Now applying limits on both sides and sandwich theorem, will get limit answer. Now if you are interested to know more about sandwich theorem, I have a separate video on sandwich theorem, the link of which is given here as well as at the end of the video. Let's look at second question. Let f be a function from set of positive integers to set of real numbers such that f1 is given and one functional equation is given to us, f1 plus 2f2 plus 3f3 so on up to plus nfn, and that is equal to n into n plus 1 into fn. This is given to us, but this is only true for n greater than equal to 2. So what I will do is I will replace n by n minus 1. So I will get f1 plus 2f2 so on up to n minus 1 fn minus 1 is equal to n minus 1 into n into fn minus 1. Now I am going to replace the value from here to here with this new value n minus 1 n into fn minus 1 in the first equation. So we will get n minus 1 n fn minus 1, something like this. Now here n and n will get cancelled out on all 3 sides. Collecting all fn terms to one side, we can write like this. Now let's find out f2 first. It is given that f1 is equal to 1. Now if I want to find f2, I will use the original equation. Original equation is f1 plus 2 times f2 is equal to 2 into 3 into f2, which gives us f2 is equal to 1 by 4. Now using the second equation, we can write for n equal to 3, 2 times f2 will be equal to 3 times f3. If I put n equal to 4, we will get 3 times f3 equal to 4 times f4. Therefore 2 times f2 is equal to 3 times f3 is equal to 4 times f4 times f of 1995, and all will be equal to 2 times f2, which is 1 by 2, because we know f2 is 1 by 4. Therefore f 1995 will be equal to 1 by 2 into 1995. Therefore the final answer is, so substituting the value of f 1995 into this, so if we simplify this, we will get the answer as 5. Now let's look at question number 3. In questions like these, it's always preferable to convert into tan inverse. So we will convert the entire series into tan inverse. I will write this as tan inverse root 3 by 5 plus tan inverse root 3 by 9 and so on. Now we need to break this root 3 by 5 such that we get difference of two terms. Let's divide numerator denominator by root 3. So I will write this as root 3 by 3 and I will write this as 5 by 3. Now if you notice, we can write this as 2 by root 3 minus 1 by root 3, and denominator we can write it as 1 plus 2 by root 3 into 1 by root 3. Similarly, we can break this in terms of 3 by root 3 minus 2 by root 3 divided by 1 plus 3 by root 3. This reduces to 2 by root 3 minus tan inverse 1 by root 3. The second term reduces to 3 by root 3 minus tan inverse 2 by root 3. Now we apply method of difference to write all the terms. This will be n plus 1 by root 3 tan inverse of n by root 3. If I add all these terms, we will get the sum as, these terms will get cancelled out. We will be left with tan inverse of n plus 1 by root 3 minus tan inverse of 1 by root 3. Now since we need s infinity, so when you apply limit n tending to infinity, we will get answer will be pi by 3. Now I completely understand that some of you might be feeling that these questions are a bit difficult, but that's okay. It's a part of process. It is meant to be that way. Problems are part of life and they will make you strong. So don't worry, just keep moving forward. Now is the time for challenge problem number 8. Thanks for watching. See you in the next video.